Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. And we're doing another video here on, algebra, and we're taking a look now at uniform motion and a system of equations. So now we're kind of combining some of the ideas we've learned in prior videos. We've learned about uniform motion before, and we just finished talking about system of equations, and now we're going to combine the two concepts into one in this demonstration video. So why don't we go ahead and take a look at our problem. So here's what we have. John left Los Angeles driving east at 130 kilometers per hour. 30 minutes later, Carl left Los Angeles driving east on the same road as John at 156 kilometers per hour. How long will it take Carl to catch up with John? So this is basic uniform motion. We have two people here. We'll just call them J, and we'll also just call them K. And they're both heading east. Both going in the same direction. The only difference is that that Carl starts 30 minutes later, or you could say half an hour later. So negative, or something like that, half an hour later, and they're both going in the same direction. That is the only difference between them. Also, Carl is traveling faster. This is why he will be able to eventually catch up with John, even though he left later. And so you should remember that when we deal with a uniform motion type situation, we're dealing with R, which stands for rate, T, which stands for time, equals D, which stands for distance. That's how it works out. So I got John over here. I'm going to make my table. This should be familiar. And so John is traveling at a rate of 130 kilometers per hour. Carl is going at 156 kilometers per hour. We don't know how long they've been traveling. So let me just finish their names here for. We don't know how long they've been traveling yet. It's not clear yet. So for that, we're going to put J for John and K for Carl. And we know that their distance is going to be 130 kilometers J and 156 kilometers K, because that's how fast they're traveling per hour. So they travel 3 hours, whatever it is, that's how fast they travel per hour. Now, here's the thing where it gets interesting. And I want to try to see if I can make this clear. We know that our equation is going to be, they're going to equal each other, because the goal is that when John and Carl catch up, when Carl catches up with John, they've traveled the same distance basically. So we can put our system of equation as follows. We can say 130J equals 156K. That's what we have. Because when Carl catches up with John, like I already mentioned, they'll have traveled the same distance. Now the question here, that you can clearly see, we have two equations. And so now the question is, well, okay, so how do we figure out J? How do we figure out K? Well, we can use substitution. Let's take that on the next slide here. So I'm going to go ahead and rewrite this. We had 130J equals 156K, like so. And now here's what we do know. We know for a fact that Carl left a half hour after John. So if you were to put that as an equation, you would put Carl, however far he traveled, or his rate or whatever, his time. We know that it's going to be John's time minus half an hour. So we're converting it, from 30 minutes to half an hour, because our rate, our time is going to be per hour, because we're kilometers per hour. So we know that Carl's time is going to be 30 minutes less, or half an hour less, than John's time. That's what we know. And since now that we know what K equals, we can plug that into the equation and try to solve it. So we're going to go ahead and do that. Let me block this off here so that we have it nice and clean. Pick a different color and move forward. So here's what we got going on here. So we got 130J equals 156. Oh, I'm running out of space. I better put this somewhere else. I'll put it down here. So we got 130J equals 156. And then inside parentheses, we're going to put J minus 1/2. Because what we're doing is that we're substituting K for J minus 1/2. Because like I mentioned before, we know that Carl traveled 30 minutes less as a minimum compared to John. So now all we got to do is we have to, distribute distribute, and then we end up with the following. We still have 130J equals 156J minus 78. That's what we have here. And so now it's just a basic equation now. We're going to go ahead and move this to the next slide here. And so I'll rewrite that for you. We have 130J equals 156J minus 78. And now this is just a basic equation. There's not a whole lot of new information here. So all we do is first we'll just subtract 156J from both sides. And so now we have negative 26J equals negative 78. That's what we have. And so again, just solving an equation, nothing new here. Divide both sides by negative 26. Divide by negative 26. And we get an answer of J equals positive 3. So John traveled for 3 hours. Now if you go back here, you can see that what we're going to do now is we're going to solve for K. That's our guy right here. And I'm going to do this right here. So we know that J equals 3. John traveled for 3 hours minus 1/2. That means that K equals K. And so K equals basically 2.5. In other words, John traveled for 3 hours, and Carl, traveling at 156 kilometers per hour, was able to catch John after 2.5 hours. That's how it worked. And so by understanding substitution, understanding system of equations, you are able to solve much more complex uniform motion type word problem situations. And that's just what makes this so beautiful in terms of how it works. So in this video, we were combining two ideas that we've been looking at in algebra here, uniform motion and also solving for a system of equation. Keep in mind that with uniform motion, you have people are moving at a constant rate, and we are trying to figure out how long it would take a second person, who we named Carl in this video, to catch up with the first person when he was traveling faster. Now, having done that, we had to set up our system of equation, and we use substitution, where we use substitution in order to cancel out one of the variables so we could solve for the other. And that is one of the beauties of being able to combine these different concepts in the mathematics. So, my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for listening. Take care.